Right, so what we did last week was we modified the model from the week before, where previously we had an assumption number 3, which said that plant shortages are not allowed. And now what we have is that plant shortages are allowed, but if they occur, then there is a cost related to them, and that is estimated to be P. So what they're doing is every unit that we're short per month, or whatever the time period is that we're looking at, incurs a cost of P. And so that could be some of these costs, as we said last week. And then yes, our favorite graph of demand in inventory, but it's really, we can't have negative demand in inventory, but so what is above the x's is the amount of inventory, and what is below is the amount we're short at that particular moment. And then when the thing arrives, we go to the top. And was this corrected then? Because I put the S on the wrong side, and now this is the right one now. Yeah, this is what we're looking at, is that we now have two decision variables. One is the size of the batch as it was before, the size of the order, and one is, well, S, which tells us how much we have when the new batch arrives, which is Q minus S is then telling us how much short we are maximum. Okay, that's what we did last week. And then we said that the cost per month looks like this. And that was sort of okay, there are some, I mean, I didn't quite explain why it's that. That's where we ended. And that's why I also said, because we didn't quite finish this, so I said that we can't really do the homework yet unless you read ahead. So I'm not checking it yet. I'll give you another week to do it. Right, so this cost is the cost of buying things, which is the same as it was before. This cost is the cost of placing orders, which is the same as it was before, and these have changed compared to the previous model. Yeah. So I should probably, okay, I'm not moving the line. So I should probably give you some justification why this is the stock holding cost now and why this is the shortage cost now. Okay. And it comes from, where does it come from? So in one cycle, what's wrong?
The lines.
Oh, yes, they're especially added for. Okay, one cycle, I mean, one period of length T, so between two orders. Between two orders. What is the stock holding cost?
You book nothing in it.
No, when we did it first, we said that the average amount in inventory is, well, before we had any S, we said that the average amount in inventory is Q over 2, and therefore, what we really did was, we looked at the area of the triangle, because the area of the triangle gives us the total inventory in this period, and then we multiply it by the cost H per, because they want some kind of idea why this might be true is, but if you have that, if you graph looked like a straight line, then you'd have to multiply how much you have, this Q, times the length you have it, times the cost per time per unit. Because that's how you get it, and if you don't, so the length of this times the height is the area of the rectangle, but we don't have a rectangle because it's decreasing, so we just take the area of the triangle and multiply it by h. And so the area of the triangle is okay, so one side, so 1/2. The right angle triangle, one side is S, and the other side is S divided by D. Okay, because D is the slope of this curve. So that's the demand rate. So cost. So the cost in that is S squared H over 2D. Okay, stock holding cost. And this other triangle, there's one. That's the shortage cost. So it's area, so area of shortage triangle, of the shortage triangle. I'll put it like this, but we understand, I hope. Well, similar, except we have Q minus S instead of S. So we have Q minus S is one side, another one is Q minus S divided by D, and this times 1/2. Okay. So similar situation in the top one, it was S times S over D, here it's Q minus S times Q minus D. 1/2, and that gives us this cost. Well, not yet. Okay, so this gives us something else. So shortage cost per cycle, or in one cycle, is Q minus S squared divided by 2D times P. And what's the length of one cycle? Is T, but what is it in terms of Q and D and the other? That's what we did 2 weeks ago. Yes. Okay.
You only need to remember the C equation.
Now you can always derive it from scratch. Stuff then.
So you won't give us a name.
I don't know. I'm not supposed to tell you, and I don't know anyway because I haven't written the questions yet. So, well, don't figure it out.
Submitted in October.
Yeah. No, November.
It's the 27th.
Yeah, it was the 15th or something like that.
As long as there's no mistakes, I'm sure.
But what they do is they file them away and sit on them for 4 months, 5 months, and then they send them to the external examiner. So it's quite a lot of.
I feel like a lot.
It's quite a large buffer.
Because it's too time consuming and nobody does it.
What is?
In the finance on account of Boris, and they've been told to take a question out because for the last 4 years nobody's been doing it because it's too time consuming. So the external examiners just said.
In which part?
Actual stuff. That's fine. Just finance.
Oh,
No,
no.
I'm not taking finance, but I need statistics.
It's not. No, it's not really that much. It's
Well,
more.
you have to take statistics and something.
Anyway, let's get back to this. The length of one cycle is Q over D. Push. Q over D. Does that need explanation, or is that something you remember? Because Q is, and then it's like the big triangle. The length is D. So that's obvious, and then everything follows because this is the cost per one cycle. What you want the cost per T. Sorry, this is the cost per T, but you want the cost per 1 month, so you have to divide this by T. When you divide it by T, it's like multiplying by D over Q, and then so
Which is why
D over Q, right, so the D disappears and Q appears. And same thing here. So then shortage cost per unit of time is Q minus S squared divided by 2D times P times 1 over T, and that is exactly what we have. Why don't I just do what?
You would take, so you'd have space to write the equals.
And similarly for inventory cost. Why don't I just start earlier?
So is that P Q minus S squared?
Oh yeah, it's squared here. It's this. Because we were trying to. Yeah, why don't I? Because I didn't.
I'm sorry, it was just
It's a
suggested.
personality fault. I don't think things over when I write them. Things happen.
That's like, am I?
Oh, there you go. So you can understand. Okay, so this is the justification for why the cost is what it is. What's just disappeared. Because you can't see, but I can. And so what I'm going to do is, what am I doing? I'm going to try and good. What am I going to do?
Copy and paste.
Yes.
Beautiful.
Try it again. Try it in your notes. Okay. Right. So now we've got this total cost. Well, you have it somewhere, so you don't have to copy it properly. Now we have this cost. What are we going to do with it? We want to find values of Q and S for which this is minimized. Right? So in the previous case, we differentiated it. Now it's two variables, so you take the partial derivatives. Well, dc by dq is also what is it? This one's minus dk over q squared. CD disappears. Oh no, what am I doing?
Breaking stuff.
I've broken it.
There you go.
Wouldn't we substitute the square root of 2kd over h for q? Why would? Because we didn't. I'm not. Last week.
I'm confused as well.
Yeah.
You can keep it for later, but yeah, why don't we substitute that for Q? Because we don't know what the optimal Q is.
Yeah, but we're just using different. And what we differentiate as well.
Yeah, no, it doesn't work. No, but what I wanted to do is stop again.
We'll just click that out.
I'll just write something. dk over q plus cd plus. Now this is s squared times h plus p over 2q and plus pq over 2 minus ps. Do you believe me?
Because that becomes 2q. You've just expanded the last two.
I've just expanded the last one. So this bracket is q squared minus 2qs plus s squared.
Obviously, the minus 2qs is where the negative.
So where it's minus 2qs, the 2 and q
Just becomes minus.
Disappear, and it just becomes minus ps. Where it's s squared, you get s squared divided by 2q times p, so that gets added to this. And where it's q squared, it divides with the q, so you get just q over 2 times p, which is this. Okay. So this is a better format for actually doing the differentiation. So now I can do it. So the way I started is the same. So it's minus dk divided by q squared. CD disappears because it's constant. The second fraction, the third term in there. S is constant now, so it'll be s squared h plus p divided by 2q squared, I hope. You should be checking this because you know how to differentiate at least. Right? And pq over 2, derivative of that is just p over 2, and minus p is a constant with respect to q. So that's one partial derivative and the other partial derivative by s. It's not an alpha, it's my attempt at this partial delta. But I'm not a calculus person, I'm not an analysis person, so I don't know.
Just explain it.
I don't need to say delta, I'm just very
Oh, okay. No, it could look like an alpha. It's okay. So the first two terms are constant, I think. So we just get, yeah, constant with respect to s. Yeah, so they're going to have an s in them. So this is s times h plus p over q is the third one, I think. Because,
what about 2?
Yeah.
Because you
Which
bring
two?
down the power and then you minus 1 from the power.
yes, I've done -1 on the power,
Oh, 2 over 2.
and then there's a 2 over 2. Yeah. pq over 2, there's no s in it. So this is simple. It's just minus p then, I think. So if we want this to be 0, because we're looking for the minimum, at least a local one. So if this is 0, that means that p, no, that means that, what do I want it to mean? And s should be p over h plus p times q. That way. We're getting out of there. P, yeah, times by q, get pq, that by h plus p, yes.
Yes.
Okay.
I don't like
Hmm?
it.
Why what?
You could have just put the Q on the top, that's what's confusing.
Oh. Well, no, but it's the same.
I know it's the same, it's just.
I don't know, I write these things. I don't even think about whether it's up or down. Just no, because I sort of I want. No, I actually want this to be like this, because then what I'm saying is there is a certain constant times q that s is. Right, so we know we have a relationship between the s and the q that we're looking for. So that's why I really actually do want it on top. Yeah, but I like it. It conveys a different idea. I don't think we're getting to the quantity today. So we're one lecture behind. That means we'll have less time.
Yeah, we have time for Christmas quiz. You can have Philip's extra lecture at Christmas if you want.
You're doing a Christmas quiz?
Yes, indeed.
Oh, we're gonna have Q.
That's what he said last week. Oh, yeah. It's like, what was it? Oh.
Oh, but he's still in question on those 6. So good, good. Oh.
Okay. So now when I go to the first derivative, so
Rearrange.
c by q equals 0. From this, what do I get?
Do you want it in terms of S?
I want the quadratic equation. So if q is not 0, which we don't want it to be 0 really, because then we would never order anything and we'd never sell anything, and that's not good. But if q is not 0, we get that.
This is gonna be long.
Okay, I would multiply this whole thing by 2q squared to get rid of the fractions, which I can do with the equation. Okay, so from this we get that pq squared, right?
He's on the
Oh, you multiply by 2.
Equals
yeah.
2dk plus s squared times h plus p. And this comes from that. Putting this to 0 and multiplying by q squared. And this continues because now I can plug in 2dk plus. And now I get s squared is this squared. So I get p squared times q squared divided by h plus p squared, but h plus p squared cancels with 1h plus p, so I only get over h plus p. So what do I get? Okay, I'll write it all up there, p squared q squared divided by h plus p. What's next? So now this I can solve for q squared. Therefore, q squared is 2dk divided by h times, and I'm writing in a stupid way again, p plus h divided by p, which we get by isolating this. Which one?
We have to square s. S squared.
Which I understand that.
You squared both of them.
Well,
Because you've
here,
got
which one is it about? This?
Yeah, I'm just understanding what p squared.
Or
It
squared s, this whole thing. So
Yeah.
p squared, q squared, h plus p squared.
doesn't use h plus p.
But then h plus p squared gets times by h plus p. So it's only the power of 1. Okay?
Right.
So you get h plus p divided by h plus p squared. So you can cancel one of them. Well, that's not so hard. Is this right? Yeah, so this seems correct. Okay, I've done this.
Yeah, rid of it.
Oh, I want to solve.
There's no x.
Yes, I want to solve for q. So okay, so what do I get here? This equals 0, right? And this equals 0. Got two equations, and I've got two unknowns, s and q. I want to solve for s and q, so I'm trying to solve for s and q. Well, this is supposed to be this, and then therefore the optimal q is the square root of 2dk, and I'm splitting it like this just to
No.
make you ask another question, but
You have to.
where? Like, where did I sub it in? Here.
No. Yeah.
It's the same place.
Because
it's the same equation.
I'm solving two equations. This and that.
Simultaneous equation.
Wait 1 minute.
Two simultaneous
Wait 1
equations.
minute. I'm
My
reading
unknowns
this the
are
wrong way.
okay.
Doesn't
That's
work.
reassuring.
Simultaneous equations are what's confusing me.
There's many equal signs.
Yeah, there is. So pq squared equals 2dk plus p squared q squared.
Yes.
Right. Let me try and work this out.
Do it on another line. That helps.
Did you work that out?
Yeah.
Does it work?
Yeah. It works.
Excellent. That means that. Okay. What is s? So S is, now we go back to this, so it's Q, this, times P over H plus P. So if I times this by P over H plus P, in there, they just reverse. So that's what it would look like it. So 2dk H times the root of P over H. Now it's a theorem because it's in a box. That's how you can tell that something is a theorem in A-level maths. It's in a box, so it's a theorem. Okay, now what I won't show is that it's actually a minimum. Feel free to verify that on your own.
Just differentiate.
Yes. Well, maybe it's a saddle point. No. No. But that's the minimum. Well, that's just because you could have the negatives and then you get something else. You get maxima. But these are the values: the optimal Q, which is the size of the order, and the optimal S, which gives us how much we should have. And then Q minus S, the difference of these two, will give us the maximum shortage.
So you've done S, the second, using the answer of the first, and the
Yes.
substitute. Okay, yeah.
And then putting it there. Yeah, that's quite right.
It's just that I can't do it with my other sons.
Ah, yeah, well, what happens is you've got P squared over H plus P squared under the square root.
Yeah.
And so then they come to. Yeah, if you're missing the steps, it should be relatively easy to work them out later when you're revising and filming.
Yeah, okay.
That's all right. Okay, so this is well, this is the theorem really. What does it do? Unless someone has a few more questions. So, these, why is it blue? Formulae give the optimal values for Q and S. Any more questions? Is that all right now?
Well,
These formulae give us the optimal values for Q and S. Okay, this was we had this example right before, and you have it in your handout. Well, we had it before in the basic EOQ model where there was no cost per shortage.
Well, it's supposed to be this.
Shortages were not allowed. Now shortages are allowed, and they cost £1.10 per speaker per month that we're short of it. So because another thing, the cost of setting up the batch was £12,000. The demand is 8,000 speakers per month. The stakeholding cost is 30 pence per speaker per month. And £1.10 is the shortage. So the optimal queue,
Oh, you
we know that the optimal queue was 25,298 speakers without shortages allowed. And that's what we have to, did you notice this in the formula?
Well, it's just Q times it.
Yeah, it's the
Yeah,
previous
so-
Q times something P plus H divided by P under a square root.
Also, it's
What?
usually time.
Oh, you don't have to.
Confused me, just Q equals Q times P, but the square root of P times H. Okay, so I'm just going to start.
Yeah, the previous Q. The non-shortages Q. Yeah. So it's the non-shortages Q times this, which gives us
28,530. Very close to 40.
very close to 40, so why didn't you say 40?
0.993.
But you can't have a 0.993.
40 in,
Just not good.
No, because that gives you more cost than
this is, but you've just rounded up to 40.
You can't make the extra one. Oh, well, you could get stuck.
Why not? You could actually
Because
do
it's demand.
28,500, 28,60, 600, whatever.
9.
Just compare the costs. There will be a very tiny difference in the cost. Make 500 or 600 in each batch.
In an exam,
Yeah.
would you mark us down if you didn't have to?
No.
Because I will write the paper, but you can't pull out 0.007
But it's
Okay.
not an actual. That's not good. That's just a demand.
So what's the shortage?
22,000.
No, it can't be that much. Is it? It's 25,298.
Times by the square root of 1.1 over 1.
Within the book.
Oh, you got it.
I mean, unless it's done something wrong. Because the shortage is Q. S is just what you actually do.
Oh, S is what you actually do have. That's right. Yeah, that's what now I believe. Yeah, right. That's what I confused last time. 20,444.
Yep.
So the maximum shortage is about 6,116.
15.
So time between two orders, two batches.
Nothing.
See if you don't put that comment for that 1,000, then
Why?
you don't think it's 8,000 then.
Oh, look, it's a big number.
What? Is the comma forbidden or is it
No,
wired?
It's the
you don't
opposite.
understand if there isn't a comma. It's like if the teacher puts down 8 million, like, oh, so what have we done wrong? You know, because we're doing mastery approach. And like, I'm not putting the commas in. I'm like, okay, but what's wrong?
The comma
with
is
this
really
number?
just there for you to be able to count the
Exactly.
variables up to the right place. If you can do that, you shouldn't need the comma.
Yeah,
If you're
well,
in
I'm
year
being a
60,
bit
you can't
inconsistent
count
because I put them
6 zeros.
somewhere and I don't put them elsewhere. Well,
Like 8,000 and 12,000 don't have them, but yeah, you're 28 and 22 do.
I just giggle when I see comments now. So it's just like,
Okay, yeah, that's just the example. You can, I don't know what the cost is.
D was in question, wasn't it? Say 8,000.
So you can try to work out, if you want, if you're interested, you can try to work out what the cost is with the shortages, which should be less than without shortages allowed. Because if it wasn't less, then we wouldn't do the shortages. Just because they're allowed doesn't mean we have to.
next lecture.
Yeah, that's a silly thing. No? So we were supposed to do quantity discounts, which is
Which I really want to do.
which you really want to do because it's the assignment.
Oh, is it?
Yeah, that's what I was showing you.
That you've just got,
Oh, no, I want to.
which is my last assignment. So
Wait,
yeah, so I think we'll have to come back to them next week. But basically, as a brief overview, quantity discounts means that with or without shortages, so we'll do it without shortages, you have a different price per unit depending on how large your batch is or how large your order size is. Okay, and then it might make sense. So for each of them, you get a different queue because you have a different. You actually get the same queue because if nothing else changes, then the queue doesn't depend on the cost of one unit. So for each of them, you get the same queue unless there's a little tweak. But you get the same queue. So, but then for some of them, it will be within one of the price brackets. So you have to work out whether that's better than actually ordering a lot more. Because then the price of the unit goes down, even though your stock holding cost goes up. But the premium you get by paying less for the item itself could make up for that. So the only thing that you really have to do there is just compare for all the larger quantities whether it doesn't make sense to order that. But we'll just yeah. So I would suggest that you read it in the book and have a look at the assignment, and then we'll just cover it very briefly because the assignment covers it quite well, and we don't have to spend too much time on it in the lecture. Yeah, so now you have all 5 of my assignments. The first 3 are due in January, remember, and the remaining 2 are due in, what did it say, March?
March 16th.
Fine.
That's Friday.
Yes. Any questions?
It's not like a proper paper coursework thing. Because if you submit on Friday, you don't have coursework until Monday.
So you can come in on Saturday, sneak in.
Yeah, they told me to do that with my research coursework, and I was like, I'm going home for the weekend. I can't.
I think I'll say goodbye to Jordan.